Shall I start?
Yes, sir. Go on.
Okay, thank you very much. Good afternoon, everybody. I am Dr. Baldev Raj. I was in CFTRI for last 36 years. Now I am retired as Senior Principal Scientist and Head of the Department of Food Packaging Technology. In this department, we have been involved in designing unit functional packages for different types of food products and prediction of the shelf life and evaluation of the shelf life of packaged food products under different environmental conditions, and the quality control of different types of packaging materials with respect to packaging. So my today's topic will be on food packaging materials, their properties and applications, and a bit I will be discussing on biodegradable materials. This is not moving right now. I'll restart and just see it. Yeah, as you see, when you go to a big market, you will see different types of packages put on the shelf life. Most of the food products are packaged in different types of packaging materials. Earlier, it started with metal containers, moved to the glass containers, and today you will see most of the food products are packaged in plastic-based containers. So they are in different forms like metal, glass, plastic, wood, paper, aluminum foils, composites, laminates, co-extruded films, and coatings. And they are available in flexible forms, little bit semi-rigid and rigid. Usually primary, secondary, and tertiary packages are used, and they are also available in different forms. If we see the global segment breakup of packaging materials, we find rigid plastics about 32%, paper and paper boards about 31%, flexible packaging 20%, metal based 15%, glass 7%, and others about 5%. And when we talk about the end users share of the plastic products, we find basically most abundantly used materials are polyethylene and polypropylenes, which are 33% and 29%, followed by PET, polyethylene terephthalate 17%, PVC 7%, and others about 14%. Now, when we talk about the plastic container, which is the major content today in food packaging, usually plastic food container technologies have been developing vigorously in plastic industries over the past 4 decades. Obviously, these plastic containers are the newcomers to the packaging field, but plastic containers have actually succeeded in replacing metal, glass, and paper containers in many applications for last 30-40 years. Various performance advantages and lower prices have been realized through continued developments in the polymer industry. Why plastics have been replacing other packaging material? This is because of some of the advantages in the plastics. They are very low cost by mass production, good productivity for manufacture of complicated shape products, design freedom, shatterproof plastic containers, there is no rusting problem, good water resistance, and easy coloring. But there are some disadvantages also. That's why their use is limited to different products. Basically, they are less heat resistance, tendency to creep is there, cracking and crazing trouble is there, static electricity generation will be there, lower dimensional stability is there, and low gas barrier properties are there. Now, among these plastics, basically it's a polymers which play a big role, and we can divide these polymers into two groups. One is thermosetting, another is thermoplastic. Thermoplastic, if you see the word, thermo means heat, plastic means elasticity, and another setting means it gets set. So what are thermoplastics? Basically, they soften and melt on heating, solidify again on cooling. In the softened state, they can be converted to a particular shape that remains after the cooling. This cycle is repeatable process. Most of the packaging material coming under this class are polyethylene, polypropylene, polystyrene, polyvinyl chloride, PET, nylon, polycarbonate, etc. Under the thermosetting, as the word says, initially they are in the liquid or solid state at room temperature. It is melted and hardened on heating. Once it is hardened on heating, it is converted into an infusible state by some chemical changes. Then it cannot be reheated and melted. So basically, example, you must have seen the melamine plates and electrical switches, bakelite, etc. That type of products comes under this category. Now let us take individual polymers. First of all, we start with the polyethylene. Basically, this is produced under high pressure using the ethylene monomer under the pressure of 1500 to 2000 atmospheric pressure with the oxygen concentration to as low as 0.06% and having the temperature at 190 to 210 degrees centigrade. Usually what polymer we get is a molecular weight up to 65,000. Usually to initiate the reaction, peroxide catalysts are required. The properties of polyethylene vary with the pressure and catalyst involved in the polymerization process and with this density which is formed because of the various processes. This is the basic chemical structure of polyethylene. You can see that ethylene molecule where C double bond C, H, it gets polymerized in the presence of catalyst into a polymer. This can get tedious to draw, so we often use a shorthand like this, that second line, ethylene being converted into C double H in bracket with the N number of monomers. And when we feeling really lazy, we just draw it like this, simply CH2 double bond CH2 converted into CH2 N number of times. This polythene can be further classified into various groups based on their density. This depends upon the pressure. It could be low pressure during the processing, intermediate pressure, high pressure. And it results into different densities. That is a very low, low density, medium density, and high density. Based on that, we keep the name low density, linear low density, medium density, high density, and high molecular high density polyethylene. In general, high pressure processes produce branch side chain. Because of the pressure, the molecule starts making side chains to expand on the polyethylene main chain. So it becomes bulky. We call it as low density polyethylene. If we reduce the pressure, the molecules remain almost in the straight lane and density increases because they are much together to each other compared to the side chain branched one. So let us see the properties of low density, high density, and high molecular high density polyethylene. Basically, LDP softens at 100 to 150 degrees centigrade, not thermally decomposed until the temperature exceeds 80 degrees centigrade. It is a crystalline in structure which ranges from 60 to 70%. It has got an excellent cold resistance. That means you can store your product in this material at very low temperature also. It withstands extreme of minus 70 degrees centigrade. So has a good water vapor transmission rate. So most of the wherever moisture barrier properties are required, we use this type of material. But as far as gases are concerned, oxygen and carbon dioxide, it's a very poor gas barrier. So we cannot use these materials where high gas barrier properties are required. It excels in heat sealability. It seals extremely very well. You can make pouches out of it. Extremely useful as a packaging material because of its low cost. It is extensively used as bags and in laminates as internal layer. So here you can see the line structure. First structure is single line where almost HDPE molecules are in straight line and they come together very easily, so density increases. And in the second, it is a LDP or LLDP where branch structures are there. Due to branching, the molecule cannot come as close as in HDPE, so their density becomes little lower than the HDPE. That's why it's called low density polyethylene. High density polyethylene, it is slightly translucent polymer compared to LDPE. Softening point slightly higher than the LDPE, that is ranging from 100 to 125 degrees centigrade. Crystallinity is also high from 75 to 90%. Highly resistant to chemicals. That's why you see most of the chemicals are packed in HDPE containers. It provides better performance as gas and water, high molecular weight, high density polyethylene vapor barrier, and high molecular weight HMHDP is widely used as crates and bigger drums. Resources are intensive product. It has got a very high strength, can be thinned and used for carrier bags in the shops. You can see here some of the market samples. LDP and HDP uses usually bags for bread, vegetables, chicken, ham or meat, for fridge and freezer containers, squeezable for salt and sauces, bowls for food storage, retail bags, yogurt and margarine tubs, and material box liners. These were different types of polyethylenes: LDP, HDP, HMHDP, linear low density polyethylene, which were little bit varying in their properties because of their densities. Now, next one we are taking is polypropylene. Just a minute. It got stuck again. I'll take it back and again restart and come to this. I don't know why it's getting stuck. Yeah. This is the lightest weight polymer with a density of 0.9 to 0.91, whereas LDP is 0.92 and HDP is 0.94. It has a good rigidity, surface hardness, brilliant surface, almost transparent appearance, sharp crystalline melting point of 162 degrees centigrade. It has got a good heat resistance and sterilization by boiling water in retortable pouches. It has got a good application, a better stress crack resistance, excellent hinge property. You can fold it and leave it. Poor in heat stability due to its high and sharp melting point. To remedy such a defect, ethylene is added at 3 to 5% to produce ethylene propylene random copolymer. Then heat sealability will be good. So this is the structure in ethylene with C double bond C. All 4 hydrogen atoms were there. But in this case, one of the hydrogen atom is replaced by methylene. So this is called propylene. In presence of catalyst or free radical mechanism, polymerization takes place and it converts into polypropylene. At every alternate carbon, methyl group will be there. This you can see when all the methyl groups are towards one side of the chain, then it is called isotactic polypropylene. When methyl groups are on alternately on the opposite sides differing, then it is called atactic polypropylene. There is little bit difference in the properties also. Isotactic will be slightly harder because one side you cannot bend, other side you can bend, whereas atactic polypropylene can bend both the sides. So it will have little more flexibility, which will have a more application. Now we call it as, when we extrude into the form of a film, we call it a cast polypropylene film. It excels in heat resistance, transparency, luster, scratch resistance, widely used as a sealant layer for snacks and retortable foods. Biaxially oriented polypropylene film. When the CPP film, that's a cast oriented film, is extended to the machine direction as well as the cross direction, it will have excellent properties. Films oriented longitudinally and in transverse direction can be done up to 7-fold. Orientation contributes to improving the strength properties, stiffness, transparency, and low temperature impact resistance. Then when we again seal this type of film, it starts shrinking, so sealing becomes a problem. So they cannot be sealed directly. In that case, we provide some coating on the film, heat sealable coatings like PVDC, polyvinylidene chloride, or nitrocellulose, or some of the acrylic heat sealing coatings. On slight heating, they provide a good sealing without shrinking the film. You must have seen most of the biscuits are today packed in BOPP film, which is coated with this type of coatings. You can just pull out that seal and it will open. That shows it is not heat sealed. It is because of the chemical sticking under heat conditions. And some are corona discharged to improve the adhesion of urethane type laminate adhesives. When we laminate it with other films, we need to provide some adhesives. Basically, they are urethane based. So it has to be given a good attraction towards the polyurethane, so it is corona discharge. Some undergo antistatic treatment and some undergo multi-layer co-extrusion coating also. Thermoform PP. It is a high heat and oil resistance, slightly thick sheet, usually milk portion cups, juice, yogurt, and butter containers, medical device trays, hospital supply trays. They are finely made from the sheet under the thermoforming conditions. It has got a good conductivity. OPP bottles provide better heat resistance and moisture barrier. Here there are some examples. Milk containers and hotel mugs are there, and tubs are there for yogurt and butter, and some of the containers are there. They are basically polypropylene based, and they are also microwavable because they can withstand high temperature. If you use polyethylene, it will start melting at that temperature, so that is not suitable. But polypropylene are all microwavable. So all these materials, just now we have discussed about polyethylene different types, polypropylene. Basically, they are called polyolefin based plastics. So these are different types of containers, HDPE containers. That jug is there, polypropylene outside. Rice is packed in PP pouch, which is highly transparent. Violet color container is polypropylene, and the bag, carry bag, is HMHDPE. And the one which is standing in the last to the left side, it is a expanded polyethylene, which is used as a cushioning material. And these are also used under the laminates. You are seeing left side 2 pouches. Metallized polyester inside polyethylene or polypropylene. Again, pouch with a handle, similar type of material. So that's how they have got a good application in food packaging. Now let us go to other material. Another one is polystyrene. In this also they are available in different forms and shapes. GPPS, general purpose polystyrene, HIPS, high impact polystyrene, EPS, expanded polystyrene. One among the major general purpose polymers are basically polyethylene, PP, PVC, and GPPS. Usually this is used for thermoforming. Polystyrene is the largest in the volume. You must have seen all these disposable containers. They are made from GPPS. by thermoforming into different shapes. Why it is so? Because they have got different properties compared to LDPE and HDPE. Basically, when we come to the polychemical structure, again as in ethylene 4 carbon atom, here one of the hydrogen atom is replaced by a benzene ring, then it is called styrene. Again, free radical mechanism, it forms a polystyrene. So GPPS is a amorphous polymer, transparent and clear appearance, hard and rigid polymer. It brittles like glass. If you fold it, it is going to break. All you would have seen is kumkum batti, kumkum dabbe. If you press it, it breaks. Its lid, if you press it, it breaks. It is a GPPS. Its softening temperature is about 95 degrees centigrade. Refractive index is of 1.6. Its density is of 1.05. That means it is density is more than water. It will sink into water. Whereas all the polyolefins, LDPE, HDPE or PP, they will be floating on the water. It has got an excellent flowability, so it can be converted into any form. Transparent thin wall drinking cups by multi-cavity molds with high cycle, high speed injection, low moisture and gas barrier. Properties are very poor, so it is basically cannot be used for packaging purpose. That's why, because it is available as a polymer, it can be converted into different forms. It is being used as a disposable containers. Advantages: vegetable packaging and radish seedling trays where good amount of moisture forming there should go out, gases exchange should take place, so we can use it for vegetables and fruits which are highly respiring materials. But disadvantages: it is a poor weatherability, tendency to become yellow in color when exposed to direct sunlight, environmental stresses, it causes cracking, poor compatibility with the fatty foods. HIPS, high impact polystyrene, usually the GPPS is converted into HIPS by mixing with a synthetic rubber such as polybutadiene is added to styrene monomer during polymerization, which improves the brittleness and flexibility. Then it is widely used for deep drawn food packaging trays for eggs, soybean, curd, ice cream container, etc. and drinking cups. Expanded polystyrene. Basically, it is a foamed polystyrene in which air is passed through that in the form of carbon dioxide. Beads possesses high rigidity and provide independent foam cells, and it becomes a very good cushioning material. And you can also use for hot products like tea or coffee. Is low in heat conduction, provides insulation against high and low temperature, shock absorbent. Typical products include insulation drinking cup, instant noodle cups, frozen food carrier boxes, and fish carrier boxes. So these are the different disposable materials. Some are plain HIPPS, and another one is last big tray is a expanded polystyrene, and you are seeing different shapes, cups and trays. And if you press them, they are likely to break. That will show it is a polystyrene. Now this is in the market, as you seeing different types of foods, basically fresh produce or meat and fish products, which has got a high moisture content. They are used specifically to pack and cover with another layer. So this is how it is being used in the market. Now let's come to the another material called polyvinyl chloride, PVC. It was abundantly used from the beginning. You must have seen earlier Bisleri bottles which had come into the markets. They were used in PVC bottles. They were quite thick because it is abundantly available at that time, but it has got certain disadvantages because of which it is going out of the market. Relatively, it's a cheap production, versatile polymer. It provides good light, oil and chemical resistance, offers good clarity, high impact resistance. Unplasticized PV is highly impermeable to oxygen and carbon dioxide, but extrusion becomes very difficult because it is very hard. So different plasticizers are added to make it soft, so that we can convert into different forms. Grades vary from rigid to soft. It contains plasticizer depending upon the application and performance. Widely used for blister packs, basically tablets you must have seen small packets, and it is covered with another foil based laminates. That's where it has a abundance use. It is also used as a electric wire insulator. Outer cover of the electric wire is made up of PVC. The reason is it is a self relatively cheap production, versatile polymer, provides good light, oil and chemical resistance. It offers good clarity, high impact resistance. Unplasticized PVC is highly impermeable to oxygen and carbon dioxide, but this unplasticized PVC is a very horny and thick hard material. Converting into different forms is very difficult. So different grades are there now which vary from rigid to soft. This is because it contains plasticizer. Depending upon the application and the performance, the amount of plasticizer can be decided. You can see in the form of a film, you can see in the form of bottle, you can see in the form of container. In different forms can be done based on the plasticizer. But there are some disadvantages. That's a combustion releases hydrochloric acid gas, and on burning it releases dioxin, which pollutes the atmosphere, and they attack the furnace wall and they pollute the air. PVC bottles are today replaced by PET containers because of these disadvantages. This polyvinyl chloride, if you see chemically, vinyl chloride where one of the hydrogen atom is replaced by chlorine, and it is again free radical mechanism, polymerization takes place and it forms a polyvinyl chloride where every alternate carbon atom will have a chlorine. And vinyl chloride can be made from acetylene where triple bond is there. By the addition of HCl, it forms vinyl chloride and it converts into polyvinyl chloride. Now, another material we talk is about nylon. Has got a better thermoformability than most other sheets. Basically, it has got a polyamide link in the polymer that is a CONH. Widely used polymers are nylon 6, nylon 66, nylon 11, 12. It depends upon the carbon atom in the monomer molecule. A biaxially oriented nylon film is superior to non-oriented films. Very good high gas barrier properties. It has got a very good strength at low temperatures, rigid and resistant to pinholes and scratches, highly heat resistance, wide range of applications it has got, good gas barrier, resistance to heat and chemicals, useful for retortable pouches and boilable pouches, used for deep drawn packaging materials for processed meat. But it is a non-heat sealable. That's why it is used lamination with the LDPE, PP, polyester. When we see about its chemical structure, basically you can see E-caprolactam, epsilon caprolactam. This is a 7-ring compound where most of the non-shown points are CH2, and the ketone group and NH. Once it breaks on hydrolysis in between, it forms a COOH and NH2. That's an amino acid. This amino acid can be further polymerized by amino group reacts with the carboxylic acid group, and carboxylic group reacts with the amino group. Then it forms CONH. So in that way, it will form a nylon 6. But when we use different adipic acid with more acidic groups and hexaminoethylene diamine, here also the reaction takes place between the acidic group and amino group, because we are using here two monomers. One is adipic acid where 6 carbon atoms are there. One is hexamethylene diamine, again 6 carbon atoms are there. When they get polymerized, we call them nylon 6,6. So that's the difference between nylon 6 and nylon 6,6. Based on this number of the carbon atoms in the monomers, they are named differently. Now, polyethylene terephthalate. You are very well aware today, PET bottles. On your shelf you will see, on your table you will see all the water bottles, all the oil bottles today used are made up of polyethylene terephthalate. It is called in short form PET. It is a very stable polymer, resistance to light, heat and chemicals. Almost a very minute amount of additives are added to this. PET is a more suitable polymer for packaging materials today. PET films provide good stiffness and clarity. It is used as the outer layer in flexible packaging material, useful as retort packaging, a very good gas barrier. If you give a coating of PVDC, polyvinylidene chloride, it gives a better barrier properties with respect to moisture as well as oxygen and carbon dioxide. We also get them thermoform containers, and non-oriented cast PET sheet is used. Sheet is poor in heat resistance, becomes sticky to 100 degrees centigrade. This is the chemical structure of the PET, where you can see the dimethyl terephthalate. Basically, two acidic groups are there on the benzene rings. It has been taken as a ester, methyl terephthalate. When it reacts with the ethylene glycol, again OH group is there, here acidic group is there, OH and acidic group reacts together and it forms a ester on both the sides of the benzene ring. Then we call it as a, this polymerization continues taking place, OH to COH group to OH, and we get the byproduct either methanol or water. So we call it as a PET, polyethylene, because ethylene glycol is there. Terephthalic acid is there, terephthalate. So polyethylene terephthalate, that is called PET. So another better materials are also available, which are at present very costly, which are called PEN. This is made from naphthalate group. Again, naphthalate group is having sp group on both the sides, and ethylene glycol is used in the same way. So we get polyethylene naphthalate. So this is a much better material, but cost is very high at present, so it could not replace PET at present. So PET beverages bottle produced by a stretch blown technology, Pepsi container, beer bottle, wine, liquor bottle, vegetable oils, wherever you see the application is there. Hot filled juices and other items are also available. Most of the mango juice, Maaza, etc. They are packed in a thick wall PET containers. It has got a high impact strength. You can throw it up to the roof level. It's not going to break. Low cost per unit. PET bottles has a greater inner volume. Sale promotion is very easy. Now you can see here different forms and shapes. All containers, bottles or jars, and even that water refillable containers are made up of PET. And in the form of roll you are seeing, they are left side polyester, polyethylene, and then polyester foil polyethylene, polyester co-extruded HDLD, and metallized polyester last two one, metallized polyester polyethylene laminate, and golden color is metallized epoxy coating, golden color is metallized polyester. Later they are printed inside and they are used for different types of food products. Here you can see different types of containers, soft drink, water bottles, beer bottles, peanut butter, salad dressing containers, food trays, boiling backpacks, etc. and retort packaging. Everywhere it has got its very good application. Another one is polycarbonate. This is an engineering polymer, excellent impact strength, heat resistance, transparency, passes more than 90% of visible rays. It absorbs a sizable quantity of UV rays, gas barrier properties, moderate, very good barrier against flavor and aroma. Polycarbonate sheets are pressure formed. They are compressed under air pressure of 3 to 4 kg per square centimeter, and forming temperature you use is 170 to 200 degrees centigrade. Polycarbonate melting point is 230 degrees centigrade, and brittle temperature is at very low -100 degrees centigrade. With that, you can see its application under different temperatures. Significantly better heat and cold resistance, possible to put pasteurized hot food products, can withstand rapid temperature increase, quick freezing of frozen foods. Most of these baby bottles you have seen, they are made up of polycarbonate. Basically, chemically, if you see, here monomers are bisphenol, where carbon atom attached with the 2-methyl group and both the sides a benzene ring provided with a hydroxy group, that is called bisphenol A. It reacts with the sodium hydroxide, forming the sodium salt of bisphenol A. Then the bisphenol A, when it is reacted with phosgene, that's a carbonyl group with both the sides, HH is replaced by chlorine, that is called phosgene gas. When it reacts with this, it forms a polycarbonate. You can see here most of the baby feeding bottle or baby water feeding bottles are made up of polycarbonate. And even the mixie parts, its jars, and many transparent materials which are unbreakable, they are made up of polycarbonate. They are microwavable as a storage container. Now we go to the next, ionomer films. These are very important ionomer films. Wherever fatty foods are concerned, basically direct oils. What happens if you pack in a film with a polyethylene laminated one? Polyethylene absorbs the oil and it becomes difficult to heat seal if oil is smeared on. But in case of ionomers, because of the ionomer group in the film, that's the ethylene, when it reacts with methacrylic acid, it has a carboxylic group and it reacts with the ethylene group. It gives a acidic group into it, which makes it more polar. Being polar in nature, even if the oil is smeared on the film, it can heat seal very well. That's called good hot pack strength. So that is the advantage. In most of the oil pouches today, you will see the inner layer is made up of ionomer film, not polyethylene. Now, property-wise, ethylene acrylic acid copolymer or ethylene methacrylic acid copolymer, that is called EMA. If we attach with the sodium or zinc salt to the acidic group, which is used for packaging meat, cheese, vegetable oil, which provides the ions of copolymers, commercially branded as Surlyn film once it is attached with the metals. This is excellent oil and grease resistance, excellent resistance to stress cracking, greater clarity, lower haziness, greater abrasion resistance, higher moisture vapor permeability due to lower crystallinity. The puncture resistance of ionomer film is double than that of LDP film of the same gauge. It provides inner layer with good heat sealability. Basically, you see that LDP, nylon, and EAA or Surlyn film for oil packaging, used for packaging meat, cheese, and vegetable oils. Now, next one is called Teflon. You must be familiar with this terminology. Basically, it is called polytetrafluoroethylene, PTFE, and commercial name is Teflon. Here in ethylene molecule, all the H atoms are replaced by fluorine. That's called tetrafluoroethylene. It's again polymerized into polytetrafluoroethylene. It used to make non-stick cooking pans. Even when it gets as hot as frying pan, not even oxygen will react with it. Very inert. when it gets as hot as frying pan, this finds a wide use as a non-stick separating surface between the thermoplastic films and the jars of the heat sealants. There are other polymers also which play their role indirectly. Polyvinyl acetate, it is called vinyl polymer. PVA is used to make wood glues as well as other adhesives in the laminations. Paper and textiles often have coatings made up of polyvinyl alcohol. Ethylene vinyl acetate copolymer. Again, this is also important. High surface stack and friction makes them difficult to handle on conventional processing machinery. EVA finds use as a stretch film for food packaging, particularly fresh meat and cling wrap purposes. It is used in co-extrusion processes for the manufacture of laminated material. Ethylene vinyl alcohol. This is another material, exceptionally high gas barrier, but it is water soluble and difficult to process. Generally, as the ethylene content increases, the barrier properties decrease. The moisture barrier properties improve and the resin process more easily. In packaging, it enhances the flavor and quality retention by preventing the oxygen from penetrating the packages. So now we summarize all these materials with respect to their properties. You are seeing here about 15 materials: LDP, HDP, CPP, BOPP, PET, PVC, PVDC, ionomer, polystyrene, PVC, EVOH, EVOI, EVA, EAA, cellulose acetate, nylon. Almost we have studied the properties and their application in our previous slides. Here, basically, we are comparing two major properties. One is called water vapor transmission rate, another one is called oxygen transmission rate. Most of the which are found to be good moisture barrier, they are actually poor gas barrier. You see the first 4-5 materials, low density, high density, PP, BOPP, they are actually considered to be good and very good water vapor barrier. High density is better than LDP and equivalent to polypropylene. Once it is oriented, barrier properties are doubled. But when you see their oxygen transmission rate, they are very high oxygen transmission rate. LDP is having the very high 7,000 to 800 and HDP, PP around 2,000, you see it. But when you go to some other material, which has got some moderate water barrier properties about 20 to 40, and their gas barrier properties are good enough, quite high, from 50 to 400, you can see. Polyvinylidene chloride. It is a material which is a very high barrier to water vapor and very good barrier to gases, oxygen and carbon dioxide. This is used as a coating on the oriented film, which makes those film further barrier to moisture as well as oxygen. You can see this has got the best property. Water vapor is 2 to 4 and oxygen transfer 5 to 25, almost the least possible. Ionomers is like polyethylene basically. Polystyrene is poor in a moisture barrier and gas barrier. Polycarbonate moderate but poor gas barrier. EVOH, very good gas barrier, moderate moisture barrier. EVA, again moderate water barrier but poor gas barrier. Ethylene acrylic acid like polyethylene, moderate moisture barrier but poor gas barrier. Cellulose acetate, no, it's not much in use. Nylon 6, it is a very poor moisture barrier, but it is considered to be good oxygen barrier. Now, you have seen all these packaging materials which we studied just now, polyethylenes in different forms: LDP, LLDP, HDP, HMHDP, Ultra HMHDP, and polypropylene, CPP, BOPP. Even in pearlized form, you see some of the milk biscuits. They are packed in a shining white milky color packet. That's a pearlized. Some of the chemicals are added. which gives the pearlized structure. Then PET, you know, polyester, polyamide, nylon, you know, PVC, you know, polystyrene, you know, polyacrylonitrile is there, another material. Ethylene acrylic acid, ethylene methacrylic acid, polycarbonate, cellulosic film. Because they have got a different properties with respect to oxygen and gas barrier. It's a good moisture barrier, poor gas barrier. It's a good gas barrier, poor moisture barrier. So we cannot use them individually. Their use is restricted. So then what we will have to do? We will have to laminate two materials. One is good moisture barrier, one is good gas barrier. When we combine them, we get newer material as the form of either laminates or co-extruded. The difference between laminate and co-extrusion is laminates, two different films are prepared of an adhesives, they are pressed with each other to get a laminate. Co-extruded means two films, they are extruded on the two different lines, and while coming out from the extrusion, they join together because of their heat, they unite together and they form a co-extrusion films. So here different films are there, laminates are there, PET LDPE, PET aluminum foil LDPE, metallized PET PE, metallized PET HD LD co-extruded, paper aluminum foil polyethylene, PET aluminum foil cast polypropylene, LDPE HDPE, and then LDPE nylon and EA with the bonding layer in between, polyamide and ionomer, LDPE, HDPE, LDPE. Different forms are there depending upon the requirements for the barrier properties, water, with respect to water and gases. We can make different combinations and we can use those laminates and co-extruded films for better shelf life of the food products. You will see in the market, these are different oil containers. All transparent bottles are made up of PET, polyethylene terephthalate, and opaque color container. That is a different types of containers. That is a for oils. Some are colored, some are white, some are yellowish. They're all HDPE containers, and most of the pouches, basically, as I told you, it is a LDPE outside. Middle layer is a nylon, and inner layer is a ethylene acrylic acid or surlane, which gives a good heat shield strength in presence of oil also. So nylon prevents the oxygen, it becomes a good oxygen barrier. Polyethylene and ionomer becomes a good moisture barrier. So it gives a good protection to the oil in the form of a pouch. When we see about the dalda, which is a semi-solid container material, co-extruded HDLD material is used because HD, when we seal, it may break up. When LD is there with that, seal will be better and pouch will be having good strength. On falling, it is not going to break. So that is the trend for the oil and fats packaging. This is what I told you. LLDP is that inner layer or outer layer, then bonding layer, polyamide, that is a nylon bonding layer, PA. Basically, most of the oil package having this type of structure. Dairy containers, most of the containers are basically polypropylene based, and pouches either HDLD or polyester polyethylene or polyester coax HDLD. Now you also see in different forms. These package forms are there. There are flexible, basically produced through extrusion blowing and molding. It includes usually for wrapping purposes, bag making purposes, envelopes, pouches, etc. Because flexibility is required to make this type of pouches or containers. Now for making bags, available on all different configurations, size, shapes and colors. Virtually they have replaced all the paper bags which were used about 20-30 years back. Commonly used materials include LDP, HDP, HMSDP, and even PP. Second one, you will see bag in box. It is two package system having a flexible bag with a rigid paperboard box with a spout for dispensing the product at the corner of the pouch, which is used for liquid like fruit juices and oils. Bigger pouches are used for bulk packaging, smaller pouches are used for unit packaging. Skin packaging. The package that takes the contour of the product, you are seeing this sauces, etc. by creating vacuum, it takes the shape of the sausage. That's called skin packaging, created by vacuum, and it is heat sealed. Basically, LDP, PVC, Sterling ionomers are used. One side, we also use paperboard for the stiffness of the container. Stretch films. Stretch films are basically used to unitize smaller individual items into a larger unit load. You must have seen this fruity type of containers. If you see in the market, it comes in the form of a crate with a board tray, and it is completely wrapped with a stretch film. Actually, loose film is placed on that, and it is heated with the hot air, and then it starts shrinking. So stretch films are basically used to unitize smaller container, individually item into a larger unit loads. The advantage of unitizations are reduced handling cost, less manpower requirement, transportation saving, protection to the commodities. In addition to the above advantages, stretch film offers further advantage, low supply cost, protection from the moisture, dirt and abrasion, reliable performance, automation, scan through optics, ease of remove. Commonly used films are EVA, LDPE, PVC films. Shrink wrap. I think last time I told you this is a shrink wrap, that was a stretch wrap. Shrink films are basically used to wrap awkwardly shaped articles which otherwise difficult to pack by other means. The application involves collision of cans, jars, bottles or cartons to avoid pilfer proofing. For cans, bottles and cartons, it is necessary to use fiberboard trays or plastic trays such as PVC or EPS. The product is packaged and sent to shrink tunnel to take the shape, reduces the packaging cost enormously. Then there are some woven sacks. Basically, woven sacks are manufactured by weaving of mono auxiliary oriented tapes of HDPE, polypropylene, and LDPE for packaging of food grains, all dry products basically, sugar, rice, salt, milk powder, onion, potatoes, etc. For high moisture sensitive foods, where higher barrier properties are required, the loose liners of LDPE or LLDPE or HMSDPE are used, or LDPE laminations is done of the woven fabric is done before stitching into the sacks so that it becomes further barrier to moisture. Netting. You must have seen today plastic nettings are produced either by a knitting or by extrusion. Netting is produced in the form of a tube and sheet in a wide variety of mesh sizes, diameters, widths and colors. HDPE and PP are the most commonly used plastic materials for netting. Plastic netting is very cost effective compared to other forms of packaging and is recyclable for packaging application. Netting has wide application in the packaging of fresh fruits and vegetables, especially root vegetables, and in the poultry industries. Plastic bottles and jars, you have already seen. Advantages in non-breakability, lightweight, lower noise level in packaging and in use, transparent, small size, flexibility of forming and in design. The major plastic materials used for bottles and jars are HDPE, LDPE, PP, PVC, polystyrene, polycarbonate, PET, and multi-layer containers are also available, like red bottle you are seeing, which is used for tomato ketchup, etc. in combination. That is called co-extruded multi-layered bottles. Basically, they are co-extruded together by blow molding. Multi-layer bottles offer new packaging possibility for improved barrier requirement and posing a threat to traditional glass and metal containers. Co-extruded bottles are already in the market for a wide range of different foods such as ketchup, sauce, and juices. The most popular material combination in use today is six-layer combination, polypropylene or HDPE, regrind materials, adhesives, EVOH, adhesives, polypropylene or HDPE. Stretch blown. This stretch blown is another technique. First, it is not as a bottle form. It is in the form of a test tube. It is extruded as a test tube, and finally it is taken to another die where bottle shape will be there, and hot air is blast into it, stretch blown molding technique provides material saving, improved clarity and good mechanical strength. Raw material savings up to 25% since thinner walls are possible because of superior mechanical strength due to biaxially orientation. Improved clarity, particularly in case of PET bottles. Improved barrier properties. Improved mechanical properties. The major materials that are processed by this process are PET and PVC. Then there are cans, which we will see in the next slide later. Pails. These are HDP containers up to 25 liter of capacity, where mouth is also as wide as the body. Basically used for the semi-solid materials like vanaspati, ghee or pickle. So in that way, this is called pail. Another is blister pack. You must have seen this small tablets packs, 10 tablets in one strip. So each portion is called blister. We will have each one will have one tablet. Blister packs are the fastest packing method world over. It contains of combination of plastic materials with paperboard to produce visual self-vending packages. The rapid growth of the self-service retailing created a demand for the innovative packaging that protects the product and also provides the sales appeal in terms of product visibility and instruction for use. The blister packs consist of a performed plastic blister, paperboard and heat sealing coat on the paperboard. The most commonly used plastic materials are blister packs are PVC, PVDC coated PVC, OPS and recently PET is also being used. Thermoform containers, you have seen most of the disposable containers or carry over containers, tub, trays, boxes, inserts are the commonest containers found by this method, particularly where very thin walls are required such that it would be difficult for a polymer to flow between the mold walls in the injection molding. So polystyrene, PVC, HDP, PET have all been used for the thermoform containers. The latest material in this field is foamed polystyrene sheet, which can be thermoformed to give trays and containers with built-in cushioning properties. These thermoform containers articles are produced either by vacuum forming or by pressure forming. The product which are commonly packaged in thermoform containers are butter, cream, yogurt, processed cheese, ready-to-eat foods, fruit, vegetables, and jam, etc. So these are the different types of plastic packaging materials, and there are the laminates, co-extrusions, their applications, and different forms, shapes, and different ways of formations. Now these all different polymers have got some international number to identify them, which is used during the recycling, so that you can easily identify the container. If it's a PET, it has been given one number throughout the world. If it is a HDP, it is given 2 number. If it's a polyvinyl chloride, it is given 3 number. And if it's a low density polyethylene, it's a 4 number. Polypropylene is 5 number. And polystyrene is given 6 number. And other materials goes as a 7 number. Metals are given somewhere 40. So this triangle which you are seeing with the arrow, that shows they can be recycled again and again. And the number is given to identify the materials, because each material has got a different melting properties. They are processed at different temperatures, so that when they are disposed of, you can separate them out easily. You will see on the PET at the bottom, there will be a triangle in which one will be written. Whether PET is written or not, it is a PET container. Similarly, for HDP, 2 will be written. And like that, those numbers are given with which you can identify them, separate them, segregate them, and put for recycling. Now we talks about the can. Basically, tin plates cans or tin free steel cans, aluminum cans, and plastic cans are available today. They are either in 2-piece, that's a container form and a lid, or 3-piece, that's a top and bottom has a different pieces and body has a different pieces. So they are, depending upon the size, they have been given different number, A1 tall, A2 1.5, A10 sizes, which are very popular. Basically, applications are high and low acid foods, fruit juices, ready to eat foods, alcoholic beverages, where they have got a very good application. You are seeing these are all different processed foods in different types of container. Some are tin-free steel where chromium coating is given. Some are tin coating is given. Somewhere slight yellow color is there. That's a epoxy coating is given on them. And you are seeing different rings on the container which gives them strength during the formation and stability during the shelf life and transportation. And these are the empty containers you are seeing. And nowadays, you are seeing that white line is just kept one above the other and welded, and one polyester coating is given on that so that reaction does not take place with the food product. Usually earlier, the edges of the sheet, they were made round and they were combined with each other in such a way that they were overlapping each other and they were compressed with a rubber layer in between to make them heat seal and seal proof completely, and different types of sealings are there in those containers. And basically steel plates are made up of carbon, sulfur, phosphorus, copper, manganese, silicon, and usually different concentrations are there: 0.04 to 0.1 to 0.01252 to 0.05 sulfur, 0.015 to 0.06% phosphorus, copper 0.2 to 0.2, manganese 0.2 to 0.6, and silicon and traces to 0.08% on the basic iron plate. So tin coated steel plates, they are called differential tin coatings also. They will have, because tin coating is inner side and outer side will have a different coatings. Usually a D150, one side 100, one side 50, and 125, one side 100 and one side 25. Basically inner one is more and outer one is less. And 50-25 micrometer. Tin free steel plates are basically chromium coated. Their tin is not coated. Aluminium containers are made up of aluminiums and different lacquer coating is given to the surface of the cans if they react with the food products. Either tin may react or iron may react or chromium may react. Depending upon the reactions, various coatings are given. They are epoxy phenolic coating, phenolic, vinyl, polyester, and sometime inside coating, outside coating, depending upon the requirement. Outside may or may not have. Inner will be having a lacquer coating which varies. Outside more lacquer coating because it's exposed to the atmosphere. Inner will be slightly less coating, 5.6 gram per square meter, and it varies from type to type containers depending upon the need, based on the uses of their application with different food products. Now, this is the chart which shows the weight of the tin plate and different sizes. As I explained you earlier, A2.5, A2, what is the size of the can, and 1 pound, 12 ounce, 16 ounce, 14 ounce. Different sizes are available and they will have a weight of the tin plate, how much each container will have, that has been given here. Now, different lacquer applications. Basically, lacquers, if no lacquer inside, it is a better quality. Basically, where products are used, fruits and vegetables, where no anthocyanin is there, mango, pineapple, guava, papaya, lychee are the product which are having good application with no lacquer inside. When lacquer is inside, then some of the food products which has got a water soluble anthocyanin like cherry, black grapes, strawberries, raspberries, etc. There we require lacquer coating inside. Now there are some sulfur resistance lacquer coating. Some of the food product like peas, cabbage, meat, they release sulfur and then they spoil the surface of the tin plate, and good reaction will be there and product will become unacceptable. In that case, sulfur resistant lacquers are coated. That is a epoxy phenolic coating. There are acid resistance coatings which are used for beverages because acid product will react easily with the container. So vinyl type of coatings are given. And aluminum cans, basically they are used for carbon beverages where foods is not processed. This is the different types of tin coating we can analyze. When we go to analytical part, there we will explain it in detail. Then glass also, it is a senior most packaging material. Capacities varies from 5 ml to 500 milliliter. Chemically inert, higher tear weight and brittle, zero permeability, can be produced in different colors, can be produced in different shapes like bottles, jar, tumbler, jugs, vials, ampoules, carboys. Uh, Lug cap with glass bottle gives good vacuum retention, good machinability. Only disadvantage is breakable. So these are different glass containers used for different types of food products being used for processing as well as unprocessed foods. Now I will touch upon a little bit bio-based and biodegradable packaging material. Basically, these materials are produced from renewable natural products derived directly from biomass like starch, cellulose, gums, pectins, lipids. By the synthesis from renewable bioderived monomers like polylactic acid or biopolyester polymerized from lactic acid monomers, directly by natural or genetically modified organism like polyhydroxy and polyhydroxybutyrate, etc. So biodegradable compostable plastics, they perform like natural biodegradable materials, paper, grass, and food. They disintegrate and biodegrade quickly within few months as part of composting process. No residues on the screens of soils, meet current standards, widely used in Japan, Europe, North America, and New Zealand. The merits are being used for production of packaging materials, can be degraded into components present in nature like carbon dioxide, water, and so be naturally recycled, free from chemicals, may well prove more healthy and safer for packaging of foods for human consumption than many conventional materials in the coming future. This has been classified into different groups. There's a bio-based polymers, polymers from renewable sources, and I take to the end starch from potato, corn, wheat, rice, tapioca, cellulose from wood, another hemicellulose from chitin and chitosan, that's C-based product, guar gum from pectin, polylactic acid, and PHA and PHB, and polycaprolactam and copolyester aliphatic, copolyester aromatic. These are some of the naturally available or from the natural material they are synthesized different materials which have a good potential in coming future. These are the different edible films: methyl cellulase, hydroxypropyl methyl cellulase, HPMC, stearic acid, palmitic acid, high amylosis, starch, gelatin, zine, soya protein isolate, casein, etc. And under the biodegradable film, regenerated cellulose film, cellulose acetate, HPMC, starch, PVOH, collagen, PHB and V, polylactic acid. They have got a application in different products like poultry, pork products, potato, onion, nut, meats, confectionery, resin, chips, which do not require very high shelf life with respect to the environmental conditions. At present, the problem is these materials are good as a eco-friendly, but they are not having very good strength to maintain the shape of the container and other things, for which a lot of researches are going on, and hopefully we will be coming out lot of materials and replacing the present synthetic material. Now this is a PLA is already in the market in the different countries for water container, milk container, and PLA for the fresh fruits to be frozen. Again in different forms, you are seeing it here, and different types of bags and containers. A lot of experiments have been done on that. And this is a polyester based resins which is fully biodegradable, and it goes to the environment in the form of uh, carbon dioxide, water, and oxygen, etc. And what are the international standards which require 60% biodegradation within 180 days? Then only it is a suitable for our eco-friendly system. capable of undergoing biological decomposition in a compost site as part of an available program, such that the plastic is not visually distinguishable and breaks down to the carbon dioxide, water, and inorganic compounds and biomass at a rate consistent with the non-compostable materials like cellulose. And different standards are there for that. Testing methods for compostability, ASTM, European, ISO, German standards, where most of them have told 60% biodegradation within 180 days. And current applications are restricted: fresh produce, shelf-life extension, what grown up from the ground should be packaged in something that grows up from the ground. Other short shelf-life foods, closed-loop waste situations, for example, in store, cafes, event management, hygiene, flushable applications, non-moisture sensitive products, plus pulses and pastas, garden and kitchen wastage bag, carrier bags, organic and natural products. So with that, I thank you for your patience hearing me almost more than an hour. Once again, thank you very much. If you have any questions, I think there is a procedure to send me the questions. I'll be replying you back. Thank you very much. Kavita? Hello?